Good morning, everybody. Plan of today, we finish the application of linear equation in one variable. And then we start to talk about linear inequality in one variable. So that's the plan today. Yesterday, we were talking about those problems, formulas. We finished number 16. Let's look at number 17. Number 17, the length of a rectangle is 6 inches more than width. The perimeter is 32 inches. Find the length and width of the rectangle. This problem is an application in geometry. Rectangle has 4 sides. The longer side is called length. The shorter side is called width. This is rectangle. And we know the length of the rectangle is 6 inches more than the width. So if you look at the sentence in blue, it's given the length is 6 inches more than the width. What else do we know about the rectangle? The perimeter is 32 inches. Perimeter. Okay, what is a perimeter? Perimeter is the distance around the figure, right? Let's say this is a rectangle. We can start any point. Say we start from this point. And we go around counterclockwise. This side length, width, another length, another width. And the distance around the figure is called a perimeter, right? So do you agree? Do you see perimeter? I use P to represent the perimeter. For the rectangle, the perimeter equals length plus width plus length plus width. Do you agree? Yes or no? Yeah. Or the perimeter equals twice of length plus twice of width. Because we have 2 sides are longer. They are length. The other 2 sides are width, right? Okay. If I divide both sides of the equation, this is an equation. This is an equation right now. If I divide both sides of the equation by 2, how many terms in the equation, by the way? How many terms in the equation? On the left, how many terms? On the left, how many terms do we have? P. 1 term, right? On the right, how many terms do we have? 2 terms. Yeah. In total, how many terms do we have? 3 terms. Yeah. So we are going to divide every single term, all of them by 2, divide by 2, divide by 2, divide by 2, to cancel the coefficient in front of L and W, right? So we have P over 2. Let me use the blue color. P over 2 equals length plus width. Or we can switch the sides of the equation. We would have length plus width equals P over 2. I want you please copy down the 2 formulas. Yeah, copy down the 2 formulas. They are the same thing. The only difference I switch the sides. Please copy down the formula. The formula tells us for a rectangle, the length plus the width is a half of the perimeter. And look at the formula here. For a rectangle, not any other figure, okay? Yeah, this is for the rectangle. For a rectangle, the length plus width, the sum of length and width is a half of P. P divided by 2 is half of it, right? And I want you to please remember this. I want you to please remember this formula. Can you repeat the formula? How do you explain the formula? L plus W equals P over 2. For a rectangle, length plus width is half of the perimeter, right? Yeah, maybe you want to write down the sentence. Yeah, for a rectangle, length plus width is half of the parameter. Is half of the parameter. Yeah, please write it down. For any rectangle, the length plus width equals half of the parameter. Okay. All right, let's look at this problem. We know the rectangle parameter is 32. We know the length is 6 inches more than the width. And what are we looking for? We are looking for the length and the width of the rectangle. So do we need to bring in a variable here? Application, we need to bring in one variable, right? Yeah. Okay, you tell me, do you want x be the length or do you want x represent the width? It doesn't matter actually, either way would work, but you make the decision. Do you want x be the width or do you want x be the length? Huh? The width, okay, that's a good choice. Okay, let's x be the width. You can say, let x be the width of the rectangle. Then the length would it be what? Is the length longer, bigger, or smaller than the width? Length is longer or smaller than the width? Longer, of course, right? So if we want to use x to represent, if we want to write length in terms of x, do we have x plus a number or x minus a number? Read the sentence in blue. The length is 6 more than the width. If width is x, what's length? L? How could we write the length in terms of x? X plus 6. Did you see that? Yeah. So if you let x be the width, then the length would be x plus 6, right? Does that make sense? Yeah, because we know the problem tells us the length is 6 more than the width. So if we decide x is the length, x is the width, then the length would be x plus 6, right? Okay. All right, so we have the variable x. We write both the length and the width in terms of x right now. How do we solve for x? How do we know? How do we find the value for x? We need an equation. Let's see, how do we set up the equation? Yeah, can you figure out a way to set up an equation involving x? Then we can solve the equation for x to find the value. The orange part, the sentence in orange, the parameter is 32, right? Parameter is 32. Yeah, maybe we can use that information to create the equation. What do you think? Parameter is 32, right? Okay, how about, tell me, what is the length? Do we have a length right now is x plus 6? Yeah, okay. What is the width? X, okay. Length plus width is a half of the parameter. Did we explain that conclusion about the parameter of the rectangle? For a rectangle, the length plus width is a half of the parameter. Tell me please, what's the value of a parameter? 32, what's half of it? 16, yeah. Half of 32, half of the parameter is 16. So that's our equation. What do you think? Yeah, the way we create the equation is we use this formula. For a rectangle, length plus width is half of the parameter. Length is x plus 6. Width is x. The sum of them is a half of the parameter. Parameter is given equals 32. Half of it is 16. So we have x plus 6 plus x equals 16. I'll give you 1 minute. Please help me to solve this equation and let me know what is the value for x. Here, the equation on the bottom, x plus 6 plus x equals 16. Tell me what's x. Yeah, it's an easy equation to solve. What's x? 5? Did I hear 5? Yes? Yeah, that's correct. That's correct. Let me solve it quickly for you. Let's simplify the left-hand side. Left-hand side, we have one x here, another x here. Could we combine them? Yeah. What do we have after we combine them? You have one x and then another x. So you have 2x. Yeah. 2x plus 6. You just bring down the 6. 6 is already on the left, and bring down the 16 on the right. We want to isolate x. So we want to get rid of the constant 6 on the left-hand side. Could we move it over? Could we move this term to the right-hand side? Yes. Subtract? Subtract 6? You mean minus 6? Oh, yeah, okay, you're right. Subtract 6. Minus 6, yeah. 2x equals 16 minus 6. Move 6 over, positive becomes negative, right? Yeah. You can subtract 6 from both sides. What is 16 minus 6? Do you see that, Ian? You move 6 over, positive becomes negative, right? Yeah. 16 minus 6, of course, equals 10. Divide both sides by 2. You have x equals 5. Then you can make a conclusion about the problem. You can answer the problem. The width is 5. The length is what? X plus 6, which is 11, right? Yeah, it's 11. Okay? Yeah, this is a very good problem. This is a very good problem. Let's summarize this problem. We are looking for the length and the width. So we bring in variable x. We let x be the width. Then the length would be x plus 6. That's given by the problem. Since the length and the width add up to half of the parameter, we have the equation right here. Length plus width is half of the parameter. We solve the equation, we find the value for x, and then we make a conclusion about the value of the length and the width. By the way, so if in the beginning, for the rectangle, suppose in the beginning we let x be the length, yes? 5 plus 6. If x is 5, then x plus 6 is 11, right? Yeah, because length is 6 inches more than the width. Yeah, that's a good question. So let's see what I was trying to say. Suppose the very beginning, we let x be the length. How do we write the width in terms of x? Suppose we start over, okay? You know what I'm saying? Yeah. Suppose we start over. In the beginning, we let x be the length. Then how do we write the width in terms of x? Yeah, x minus 6. Do you guys see that? Yeah. So either way would be okay. But once you determine which quantity you want x to represent for, you have to keep the consistent. You cannot change in the middle. Okay, that would be the last problem about the application. Let's move to 2.9. Linear inequality in one variable. Yeah, in this section, we are going to look at how do we solve a linear inequality in one variable. Before that, we want to see the definition of linear inequality in one variable. So please look at this part. We are solving linear inequality in one variable, this section, right? Before that, we want to know what is a linear inequality in one variable. So linear inequality in one variable. Look at the name. If we change this word inequality to equation, linear equation in one variable has been the thing we have been talking about the very beginning of this chapter 2, right? Yeah, linear equation in one variable. We learn how do we solve it and how do we apply it. And today we're going to learn linear inequality in one variable. The only difference is that here is the equation, here is the inequality. That actually is the main difference. Yeah. So how do we know if an inequality, a linear inequality in one variable? If the following three conditions are satisfied, then that is an inequality. That is a linear inequality in one variable. Let me explain the three conditions. Firstly, the expression has one of those four inequality symbols. Look at those four in orange. Yeah, the expression has one of the four inequality symbols. Sometimes you have more than one, but we start from only contain one. The inequality only contains one of those symbols. This is bigger than, or strictly bigger than, or greater than. This is strictly less than, right? This is bigger than or equal to. Bigger than or equal to can also be interpreted as at least. Bigger than or equal to 5 means at least 5, right? Do you see the same? They are the same, right? This less than or equal to, less than or equal to can also be understood as at most. For example, less than or equal to 10, then at most 10, right? No more than 10. The 10 is the maximum, yeah. So there are different ways to understand a certain inequality symbol. So we'll take time to fill the symbol later. So the first condition, the expression contains one of the four inequality symbols. That's the number one. So the expression is an inequality, right? You don't see equal sign anymore. If you see equal sign, that is an equation. Yeah. You see inequality symbol, so that is an inequality. Number two, the inequality only has one variable. Sometimes, most of the time, we use the variable x to represent the only variable. Sometimes maybe we use y. Maybe we use t. If you work on your math assignment, maybe you see different variables, right? Different letters. But anyway, you only see one variable. You don't have more than one. Number three, the only one variable, the exponent on the shoulder of the only one variable is 1. You don't see square, you don't see cube, you don't see -1, you don't see half, right? Yeah. So if the variable appears on the shoulder of the variable, the degree almost be 1. When the degree of the variable is 1, actually you don't see it. We don't really write the first power out, right? You see what I'm talking about? Yeah. So if an inequality has all the three conditions, satisfy all the three conditions, then that is a linear inequality in one variable. Okay, yeah, that is a linear inequality in one variable. For example, look at here, x plus 5 is less than 0. Is this a linear inequality in one variable? Let's look at the three conditions, right? Condition number 1, well, it has an inequality symbol. Condition number 2 only has one variable. Condition 3, the exponent on the shoulder of the variable is 1. So yes, this is a linear linear inequality in one variable, right? Do you see that? Yeah, you can quickly look at the three conditions. If it satisfies all the three conditions, that's a linear inequality in one variable. Look at this one. Z minus 3/4 bigger than or equal to 5. It has an inequality symbol. one variable only, which is z. The exponent on the shoulder of z is 1. So yes, this is also a linear inequality in one variable. Linear means the exponent has to be 1. You don't see square or cube. Look at this one. 2k plus 5 less than or equal to 10. Inequality symbol, one variable k. On the shoulder of k, exponent is 1, right? Yes, this is also a linear inequality in one variable. The last one, x is bigger than -1. Inequality symbol bigger than one variable. Exponent on the shoulder of variable is 1, right? See that? So it's pretty easy to identify what is a linear inequality in one variable. Of course, our focus is to see how do we solve a linear inequality in one variable. Means we're gonna find a solution or solutions for a given linear inequality in one variable. But before we focus on how do we solve it, I want to talk about a little bit about solutions. We're gonna use this inequality as an example. Okay? Yeah, we're gonna use this inequality as an example to demonstrate how do we understand a solution of a linear inequality in one variable. Okay, yeah, I'm going to give you some numbers. Okay, yeah, I'll give you 0, 1, -5, -6, 10, -10. Yeah, or just randomly wrote some numbers. Let's see if number 0 is solution of this inequality. Yeah, we are trying to understand what is a solution for a given linear inequality in one variable. One variable only x, right? Yeah. If we replace variable x with the value, and the value satisfies the inequality, in other words, make the inequality be true, then the number is a solution. A solution, okay, of the inequality. For example, let's see 0. We want to know if 0 a solution of the inequality or not. So we plug in. Very easy, okay? It's very easy to determine. We plug in x equals 0. Let's see what happens. Let's plug in x equals 0 here. 0 plus 5 less than 0. 0 plus 5 less than 0. Is that true statement or contradiction? 0 plus 5 less than 0. So 5 less than 0. Obviously, the contradiction, right? 5 is not less than 0. Okay, so when we plug in x equals 0, we got a contradiction. That means 0 does not satisfy the inequality. Means 0 is not a solution. Yes, awesome, very good. It's easy, right? It's easy to determine. 0 is not. Let's see 1. We plug in 1. 1 plus 5 less than 0. True statement or contradiction? 1 plus 5 equals less than 0. 1 plus 5 less than 0 means 6 is less than 0, right? Of course, that's a contradiction as well, right? Do you see that? Okay, let's see -5. Let's plug in -5 here. -5 plus 5 less than 0. Write it down. -5 plus 5 less than 0. What do you have? Do you have a true statement or contradiction? You would have 95 plus 5 less than 0. So that is 0 less than 0, right? 0 less than itself. Is that true statement or contradiction? Contradiction, you are right. Yeah. Because the number is not less than itself. So 95 doesn't work either. 96. Let's plug in 96. 96 plus 5. What is 96 plus 5? 91. Is 91 less than 0? Yeah, so is -6 a solution? Yeah? Yeah, because when we plug in, we got a true statement, right? Finally, we found one solution. Let's see 10. If we plug in 10, Do we have a contradiction or true statement? Do the math. 10 plus 5 less than 0. Contradiction. Yeah. What about negative 10? Negative 10 plus 5. Yeah, negative 5, you're right. Is negative 5 less than 0? So we got another solution, right? Yeah, I can write more numbers. We can determine if they are solutions or not. So now I have a question. How many solutions do you think this inequality has? How many solutions? We did find two solutions. How many solutions do you think this inequality has? Only 2? And what if I give you negative 50 here? It will be another solution, right? You see what I'm talking about? Yeah, if I give you negative 11, it also works. Or negative 12, or negative 5.1. So how many solutions do you think this inequality have? Huh? How many solutions? Tell me a number. Infinitely many? Yeah, infinitely many. Actually, uncountably many solutions. This inequality has infinitely many solutions. Okay? Yeah, most of the cases, the inequality has infinitely many solutions. Yeah, so through this example, we see the concept of a solution of the inequality. And we also have an idea about how many solutions does this inequality have, right? Yeah. We know we understand it has infinitely many solutions. If we put all the solutions together, make a set, we got a solution set of the inequality. So today, the focus is to find the solution set for a given linear inequality in one variable. That's the focus today, okay? So far so good? Any questions so far? What is a linear inequality in one variable? What is a solution of a linear inequality in one variable? What is the solution set of a linear inequality in one variable? Okay, now I think we are ready to focus on how do we solve a linear inequality in one variable, okay? Firstly, please write down this paragraph on your note. It's very colorful, yeah. The only difference between solving linear equation in one variable and solving a linear inequality in one variable is when you multiply or divide both sides of an inequality by the same negative number, you must switch the direction of the inequality symbol. Okay, yeah, copy them down first, and then we're gonna make sense of it. The only difference between what? Solving a linear equation in one variable. That's what we have been doing from the beginning of this chapter, right? Solving a linear equation in one variable. We have learned a few properties, and we also learned the transposition of terms. Yeah. We should know how to solve a linear equation in one variable. Today we're gonna learn how do we solve a linear inequality in one variable, right? Yeah. There's only one difference between the two things. What's the only difference? The only difference is when we multiply or divide, it's only multiply or divide. It didn't say addition. It didn't say adding or subtracting, okay? Means it does not apply to addition and subtraction, only apply to multiply and divide. When you multiply or divide both sides of an inequality, by what? By a negative number. They didn't say positive number, okay? It has to be it has to be a negative number. Then you must do a thing. Do what? You have to switch the direction of the inequality symbol. That's the thing we need to do. Yeah, let me know after you finish the copying. Let me know after you finish the copy. Did you finish the copy? The only difference between the two things is under a certain condition, we have to switch or flip the direction of the inequality symbol. When do we do that? When we multiply or divide both sides of the inequality by a negative number. And let me know once you finish the writing. You done? Okay. We all know 1 is less than 2, right? We all know 1 is less than 2. Okay. So now I want to multiply both sides of this inequality by a negative number. Yeah, I want to multiply by -2. Let's see what happened to each side of the inequality. Yeah, I'm going to multiply by -2. Okay, multiply by -2. Multiply by -2. By -2. Okay, 1 times -2. The left-hand side, 1 times -2. What do you have? 1 times -2. What do you have? Hello, what is 1 times -2? Left-hand side times -2. Huh? Yeah, -2. Very good. Right-hand side times -2. Tell me what do you have? Right-hand side is 2. 2 times the -2. -4. -4. Okay. Look at the -2 and the -4. Which one is bigger? Yeah, -2 is bigger. We talked about this before, right? When we compare two negative numbers, then one has a smaller absolute value is bigger. Yeah, I can show you quickly here. This is the origin. This is -2. This is -4. -2 is to the right of the -4, right? And -2 is closer to the origin. -4 is further away from the origin. So -4 is less than -2. Does that make sense? So do you see when we multiply? Yeah, you see, when we multiply both sides of the inequality by a negative number, the same negative number, we do have to flip the direction of the inequality. Do you see that? Yeah, so we need to remember when we multiply both sides of an inequality by the same negative number, we need to remember to flip the inequality symbol, the direction of the inequality symbol. Okay, so now let's see division. I want to divide both sides. Divide both sides by a negative number. Let's see, how about -2 here, -2 here. Yeah, divide each side of the inequality by -2. This time we're going to divide by -2. Left-hand side is 1. What do we have when we divide 1 by -2? Divide 1 by -2, what do we have? Divide 1 by -2. Do we have a -half? Yes or no? Yes? Okay, very good. Right-hand side is 2. Let's divide the right-hand side by -2. Tell me what is right-hand side 2 divided by -2? What is 2 divided by -2? -1. Very good. -1. Okay, let's see. Left-hand side, -half. Right-hand side, -1. which is bigger, which is smaller. -half is bigger. Let me draw the real number line again for you. This is the origin, right? If -1 is here, the middle point between -1 and 0, that is -half, right? Remember when we compare two negative number, the number has a smaller absolute value is bigger. -half is bigger than -1. Do you see that? Yeah, so again we see when we have inequality, when we divide both sides of the inequality by the same negative number, we do have to flip the direction of the inequality. Do you see that? Yeah, earlier we have to multiply, right, by a negative number. Now divide by a negative number. So we need to remember, in those two cases, we have to flip the direction of the inequality symbol. Okay, now I'm gonna try other things. What if right now I'm gonna multiply by +2? Not a negative number, a positive number. Let's say +2. Okay, left hand side is 1. 1 times 2, of course we know is 2, right? Right hand side is 2. 2 times 2, what do we have? 4. Which one is bigger? You see? Does the inequality symbol change the direction? It doesn't, right? Yeah, when you multiply by a positive number, you do not flip the direction of the inequality symbol. Double 1, you get 2. Double 2, you get 4. Right hand side still bigger than the left hand side, right? Do you see that? Yeah, so when we multiply by a positive number, we do not do that. Okay, what if we divide by a positive number? What if we divide both sides of the inequality by +2? Left hand side 1 divided by 2, we have a half, right? Right hand side 2 divided by 2, we have 1, right? Which one is bigger? Which one is bigger? Half and 1. 1 is bigger. So the inequality symbol does not change. You see that? It doesn't change, right? Okay, so when we divide or multiply positive number, we do not flip the inequality symbol. That's my point here. Okay? What if we do addition or subtraction? For example, we have an inequality. We plus both sides with a positive number, let's say 3. Left hand side 1 plus 3. 1 plus 3. What do we have? 1 plus 3. Right hand side 2 plus 3. 2 plus 3. Which one is bigger? Right hand side still bigger, right? Yeah. So you see, when you're adding a number, you do not change the direction of the inequality symbol. Yeah. When you minus or subtract, let's see what do we have. Let's say we subtract each side of the inequality by 3. Yeah. 1 minus 3, 2 minus 3. Which one is bigger? 91 is bigger, right? So my point here is the rule, the sentence in the box does not apply for addition or subtraction. And you only need to flip the inequality symbol of the inequality when you multiply or divide both sides by a negative number. If you multiply or divide by a positive number, you don't flip the direction of the inequality symbol either. So am I clear enough about this rule? Am I clear about that? Yeah. Everything else, it also means everything else when we solve an inequality, besides this, except this, everything else would be the same with solving an equation. Yeah, we can transposition of terms. We can move the terms around from one side to the other side, right? We just need to change the sign in front of it. Yeah. Okay. Now let's actually work on solving linear inequality in one variable. Yeah. We have this example 1. This example 1 has 4 problems. Yeah, let's look at them. Number 1, the inequality is 4x minus 4x bigger than negative 24. I remember when we just start to learn solving an equation, linear equation in one variable, I draw a bubble and I write a sentence in the bubble. Do you guys still remember what I write? What did I write in the bubble? When we learn solving a linear equation in one variable. Do you remember what did I write in the bubble? Isolate x on the, on the left. Thank you. You remember that. Same with here. You remember this rule says everything would be the same, except when we multiply or divide both sides by a negative number, we have to switch the direction of the inequality symbol. Everything else is the same. Yeah, when we solve a linear inequality in one variable, the goal is still isolate x on the left. Yeah, we don't isolate on the right hand side. Yeah, we do on the left is better by convention. Let's get started. Let's look at the left hand side. Left hand side of this inequality is 4x, right? We want to isolate the x. Do we need to get rid of the 4? Do we need to get rid of the 4? How do we get rid of the 4? Divided by 4, right? Divided by 4. Yeah, perfect. Okay, so we are going to divide each side of the inequality by 4. Hold on a second. Do we need to flip the inequality symbol here? Why not? It's a positive number, yeah. So we are dividing by positive 4, so we don't have to change the direction of the inequality symbol. Very good. So 4 over 4 cancel out. We have x isolated on the left-hand side. Right, we bring down this inequality symbol. Yeah, bring it down. On the right-hand side, what is the negative 24 divided by 4? A positive 6? Yeah, be careful with the sign. Negative 6. Yeah. So we have x isolated on the left. However, that's not the whole story yet. We have to graph the solution set and write the solution set in an interval notation. So we're going to elaborate on that, okay? Yeah. So we have the variable x isolated on the left. Now we are going to interpret the solution. Yeah. It means, yeah, so this means all the real numbers that is bigger than negative 6 are solutions of the given inequality. Yeah, how do we understand the bottom, like when we have x isolated on the left, how do we understand that? X is bigger than negative 6 means this inequality, the original inequality, has infinitely many solutions. All of the solutions are real numbers bigger than negative 6. Yeah, as long as the number is bigger than negative 6, they will satisfy the inequality. Yeah, those numbers are all solutions. They put it together, we get a solution set. Yeah, so that's how we interpret the result. Remember I mentioned when we solve an inequality, isolating x on the left is not the whole story yet. Yeah, we have to graph the solution set on the real number line. Okay, let me draw the real number line here. This is a real number line. We're going to graph the solution set on the real number line. Let's say this is orange. Yeah, we're going to graph x is bigger than negative 6. We're going to graph all the real numbers bigger than negative 6. So we need a label where is negative 6 first, right? Yeah, where is negative 6? Yeah, to the left of orange, 6 units, right? 1, 2, 3, 4, 5, 6. Yeah, this is negative 6. All the real numbers bigger than negative 6. So we go to the right or go to the left. Bigger than negative, yeah, the other direction. Bigger than, so to the right. All those real numbers, right? Yeah, covered by the red line. Yeah, all the real numbers are covered by red color. Those numbers are bigger than negative 6, right? And what about -6 itself? Is a -6 a solution? If you plug in -6 is bigger than -6, is a solution or not? It's not a solution, right? Yeah. So when the endpoint is not a solution, we are going to use a parenthesis. We are going to draw a parenthesis at that point, to demonstrate the point -6 is not in the solution set. It's not a solution. Okay, do you see what I'm talking about? Yeah, this is how do we graph solution set of the inequality. What we just did is graphing the solution set of the given inequality. Yeah, we found out all the real numbers bigger than -6, those are solutions. Yeah, so there would be all the points to the right of -6, right? But not including -6 itself, so we have a parenthesis here. That's how do we display the endpoint itself is not in the solution. Yeah, that's one thing. Graph the solution set. Another thing, write the solution set in the interval notation. Interval notation. Yeah, we need to learn this, okay? Yeah, interval notation. Then we have to know what is an interval, right? I'm gonna give you my definition about interval. Interval, an interval, in VAL is one whole piece, or one single whole piece, one whole single piece, PIECE, on the real number line without any discontinuity. Okay, this is the definition about the interval. Can you write it down, or at least understand it? An interval, one interval, okay? One interval is one whole piece on the real number line without any disconnection in between, in the middle. I'll explain once you have it copied down. One single piece, one whole piece on the real number line. An interval? No, the last one. Discontinuity or disconnection. Yeah, this is my way to give the definition. Yes? Yeah. Without any discontinuity. Yeah. An interval is one whole single piece on the real number line without any disconnection. Let me explain, okay? Yeah, what does that mean? So earlier I have this, okay, look here. This is one whole piece, right? You know what I'm saying? But if I have this is two pieces, you see what I'm talking about? So do you see this red part on the real number line? If I could pick it up from here, I can lift it at one attempt. Do you see what I'm talking about? I can pick it up in one piece. Do you see what I'm talking about? Then what is not one interval? For example, on the real number line, we have intervals like this. So I pick one, this is the one interval, right? Because when I lift this part, I will not touch this part. Do you see what I'm talking about? So I have to do twice. So that is two intervals. One interval means you can pick it up at one time. So it is one single piece without any disconnection between it. Does that make any sense? It's just the definition. Does that make any sense? Okay. So once we understand what is the interval, what is the Y interval, let's see how do we write the solution set in the interval notation. Look at this one interval. Help me to identify the left end point of the interval. Left end point. Left end point. Left end point is the left bound of the piece of the interval. And do we have a left end point? Or where does the piece stop on the left? On the left, where does the piece stop at? 96, yeah, 96 is left end point, okay? Yeah, 96 is the left end point. So we write the left end point here. And help me to identify the right end point. Look at the piece. On the right, do we have a bound? Or do we have a point the piece stops there? Yes or no? This arrowhead means continue, continue, forever, forever. Yes or no? Where? Is it continue, continue, forever, forever? It does not have a bound. So when it does not have a bound on the right end point, this time the right end point, is a positive infinity. Okay, this notation is called a positive infinity, okay? Yeah, so we identify for the piece, the interval, we identify the left end point, right end point, we use a comma to separate them, And then we look at -6. Since the -6 is not a solution, we use parentheses to frame -6. Consistent with the notation we use when we graph the solution set, right? Because -6 is not a part of solution, so we use a parenthesis here. You see that? On the right hand side, not on the right side, I mean at the right, at the positive infinity, as long as if the end point is infinity, either positive infinity or negative infinity, we always use a parenthesis to frame infinity. Because infinity, it doesn't actually, you can actually never reach it, right? So it's infinity. So we use a parenthesis to frame the infinity. Does that make sense? Yeah, I just showed you how do we write a solution set. If the solution set is one interval, how do we write the solution set in the interval notation? This is interval notation. You identify the left end point, identify the right end point, use a comma to separate them. And then decide how do we frame the two end points. We always use a parenthesis to frame infinity. For the finite number, if the end point is a finite number, like 96, if the end point is a solution, we use a bracket. We'll see that later in other examples. If the end point is not a solution in itself, we use a parenthesis. Like in this case, we use a parenthesis, right? Reason is -6 is not a solution, it's not a part of the solution. And same when we graph the solution set, we use a parenthesis here as well. It's consistent. And now this problem finally is complete. Yeah, let's make a summary. When we solve a linear inequality in one variable, we have to do the following. Firstly, we try to isolate the x on the left. Right? Yeah. And we have to know how do we understand the result once we have x isolated on the left. Secondly, we have to graph the solution set in a real number line. Thirdly, we have to write the solution set in the interval notation. So we need to do three things. It's more complicated than solving an equation. When we solve an equation, once we have the x isolated on one side, we basically done, right? We are done. But not when we solve an inequality. When we solve an inequality, we have to do more things: graphing and interval notation, those things. Any question about this number one? If not, let's move to number two. Let's move to number two. Question number two. Is 93x less than or equal to 6? Less than or equal to 6, not a B. Yeah, okay, that's the second inequality. That's the second inequality. Number two, -3x is less than or equal to 6. Less than or equal to 6, yeah. Let's see, how do we solve this inequality? Remember, we need to do three things, right? The first thing, we need to isolate x on the left. Yeah, if I draw a bubble here, you know I'm gonna write on in the bubble. Isolate x on the left. Let's see, let's look at the left-hand side. Yeah, let's look at the left-hand side of the inequality. It's a -3x, right? 93 times x. X is not isolated. X has a coefficient which is 93, right? Yeah, how do we isolate the x on the left? How do we do it? Yeah, divided by 93, very good. So we are going to divide both sides by 93, Divide both sides by 93. Do we need to do something here? Yeah, look at the paragraph you wrote down earlier. The only difference between solving an equation, yeah, what do we do? Did we just divide both sides of this inequality by a negative number? Yeah, we need to switch the direction of the inequality symbol. Flip it, right? It was less than or equal to. Now we're gonna put it as bigger than or equal to. You see that? Super, super important. You have to remember that. Okay, once we divide the left-hand side by 93, x is isolated on the left. On the right, what is 6 divided by 93? What is 6 divided by -3? -2, right? Very good, -2. Yeah, so we isolated x on the left. How do we interpret that? Once we have x isolated on the left, we can interpret the solution. The solution set of this inequality includes all the real numbers bigger than or equal to -2. Okay? Yeah, all the real numbers no less than -2. Those numbers are all solutions. Yeah, so that's we have to, once we have x isolated on the left, we need to know how do we interpret the solution set of the inequality. Okay, now second thing, we're gonna graph the solution set on the real number line. Okay, yeah. Where is -2? Let's say if 0 is here, where is -2? 2 units to the left of the orange, right? Okay. Bigger than or equal to -2. So do we go to the right or do we go to the left? Bigger than or equal to -2. To the right, you are right. All the numbers to the right of -2, those are bigger than -2. What about -2 itself? What about -2 itself? Is -2 a solution? Yeah, if we plug in, we have -2 bigger than or equal to -2. Is that a true statement or contradiction? Is a true statement. Yeah, let me make a difference between those two things. This is a contradiction because the number is not less than itself, but this is a true statement. A number is no less than itself. You see that? A number is no less than itself. Yeah, so be very careful with the things, with the two things. Since -2 is a solution. This time, we are going to use a bracket at -2. You see that? Is the way we graph a solution set. That's the rules we're gonna follow. So far, so good. Number 3, yeah, the third thing we need to do is to write the solution set in the interval notation. So this is one whole piece, right? Do you see that? So it's one interval. Yeah. Tell me what's the left end point of the interval? What's the left end point of the interval? -2. What's the right end point of the interval? Infinity, right? Let me rewrite the infinity. Infinity is like 8, but you rotated 90 degrees. And then you use a comma to separate the left end point and the right end point. Remember, always use parentheses to frame infinity. At -2, are we gonna use a parentheses or bracket? Bracket, awesome. So this interval is left close. It is bracket is close. Right open, it is a parenthesis open. Left close, right open interval. Okay? Any questions? Yes? Yeah, that's a good question. We use the bracket when the end point is in the solution set. When the end point itself is a solution, satisfies the inequality, we use a bracket. If the end point itself does not satisfy the inequality, we use a parenthesis, like the previous example. Yeah, that's the rule. Yeah, if you plug in -2, you're gonna true statement, right? Means the -2 is a solution. So you use a bracket. Yeah, let's feel like a bracket is like a thicker than the parentheses, right? Because the -2 itself is a solution. Do you feel that? It's like thicker because -2 is a solution, right? If it's open, means the end point is not a solution, it's like a lighter. Because we don't have anything at -2. Any question about the number 2? Yeah, how do we isolate the x? How do we graph the solution set? How do we write the solution set in the interval notation? Then let's see number 3. Let's see number 3. -2/3 at 8. -2/3 bigger than or equal to 8. -2/3x bigger than or equal to 8. All right. Let's see, how do we solve number 3? The inequality is a -2/3 times x bigger than or equal to 8. How do we get started? If I draw a bubble, what do you think I'm going to write in the bubble? Isolate x on the left, right? Yeah. So how do we get rid of the coefficient -2/3? We did a similar thing when we solved equation. And I made you to write down a sentence if you still remember that. When we solve equation, I made you to write down a sentence that if the coefficient of the variable is a fraction, we are going to multiply both sides of the equation by the reciprocal of the fraction. Do you remember that? Yeah, if you listened to me, you should have that sentence in your note. Okay, same thing here. Instead of dividing, yeah, we could divide both sides by the fraction coefficient, right? But it's more troublesome. More convenient way to process this is to multiply both sides of the inequality by the reciprocal of the coefficient. The coefficient, I colored it as blue. Yeah. Coefficient is -2/3. Tell me what's the reciprocal? What's the reciprocal? Reciprocal, remember, is also called a multiplicative inverse. Bless you. Huh? Yeah, reciprocal. reciprocal. Firstly, do we have the same sign? Do we change the sign? Would negative still be negative, reciprocal? Reciprocal does not change the sign, okay? Positive would be still positive, negative would be still negative. And then we flip top and bottom. That's a reciprocal, right? Yeah, that's what you meant. Yeah, okay, very good. Do you see that? Yeah? Okay, we are going to multiply. We are going to multiply both sides by -3 or 2. -3 or 2. Okay, that's what we're going to do. We are going to multiply the left-hand side by -3 over 2. We are going to multiply right-hand side by -3 over 2. Okay, what about the inequality symbol? Do we need to do anything or do we just bring it down? We multiply the left-hand side by -3 over 2. We multiply the right-hand side by -3 over 2. What about the inequality symbol? Do we do anything? We multiply both sides by a negative number. Do we need to do something? Do we switch the direction? Yes or no? We switch the direction because we multiplied by a negative number. Do you see that? Okay, so the left-hand side, when you see the left-hand side is pretty complicated, right? You don't have to worry about that. If your thought is clear, you know the reason you multiply the left-hand side by the reciprocal is to get rid of the coefficient, right? So you know x is going to be isolated. After that, on the left, we would only have x because associated to the plotting, you can multiply -3 over 2 by -2 over 3. They are 1, right? And then you multiply x, so 1 times x. Do you see that? Right-hand side, +8 times -3 over 2. So the answer is a positive or negative? Yeah, determine the sign first. And then I'm going to write 8 as 8 over 1. And I copy 3 over 2. And you help me to find the answer. Lauren, could you help me to? Yeah, -12, exactly. This direction, A and 2. 2 is GCF, right? 2 becomes 1. 8 becomes 4. So you have no number in the bottom. The denominator is gone. Numerator is 4 times 3 is 12, so -12. Do you see that? Do you see that -12? Yes? Okay, let's interpret the result. The inequality has solutions, or the solution set of the inequality. The solution set of the inequality contains all the real numbers no more than -12. No more than, at most, -12. Yeah, all the real numbers less than or equal to -12. All those numbers are solutions of the inequality. That's how we understand it. Graph the solution. Real number line. Let's say if this is 0, where is the -12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, -12 is right here, right? This is -12, right? Okay, at the -12, are we gonna go to the right or go to the left this time? Go to the right or left? Left, yeah, less than. Less than or equal to -12. So to the left, because our real numbers to the left of -12 are less than -12. Okay, at -12, yeah, you tell me, at -12, at -12, are we gonna have a parenthesis or bracket? Depends on if -12 is solution or not. You tell me, is the negative 12 a solution or not? Well, if we plug in negative 12 less than or equal to negative 12, true statement or contradiction? True statement. So where do you see that? The true statement, right? So means the negative 12 is also a solution. So bracket or parentheses? Bracket, you're right, bracket. Bracket is thicker, right? Yeah, because we have more, because negative 12 also included. Yeah, if the endpoint is included, bracket. If the endpoint is not included, excluded, we use parentheses. Also, you can see the difference. Left hand bracket, right hand bracket, left hand parentheses, right hand parentheses. You understand that, right? Yeah. So you don't draw this here. That would be weird. Because the negative 12 is the right endpoint. So you're gonna use a right hand bracket here, right hand bracket. Okay, the last thing, write the solution set in the interval notation. Interval notation. Tell me what's the left endpoint? Left endpoint. Yeah, negative infinity. You're right. Negative infinity. Perfect. What's the right endpoint? Negative 12. By the way, you will have to always write the left endpoint to the left of the right endpoint. You don't switch the order, okay? Yeah, you have to write the left endpoint to the left of the right endpoint. And then you use a comma to separate the two endpoints. Infinity, always use parentheses. At negative 12, the same with the graph. Since negative 12 is included, so we have a bracket there, right? And that's how do we complete this problem. That's number 3. So far so good. Then let's move to number 4. Look at, yeah. Number 4 is more complicated. And number 4, inequality symbol is right here. Right hand side is pretty simple. 20, yes? Yeah. Left hand side is more complicated. Same thing. We still have to try to isolate x on the left, right? Yeah. Just like when we solve addition. The left hand side at this point is too complicated. Let's simplify it. Do we have a parenthesis on the left? Do we have a parenthesis on the left? What's the coefficient of the parentheses? Perfect. Negative 1 is the parenthesis. Yeah. So you want to write down a rule. When the coefficient of the parenthesis is negative 1, yeah, the way you remove the parenthesis is to change every single number in the parenthesis to its opposite. I think we had that covered before when we learned distributive property. Yeah, because negative 1 times 3, because negative 1 times 3 is negative 3. Negative 1 times x is negative x. Right? Do you see that? Yeah, when the coefficient of the parenthesis is negative 1, you remove the parenthesis by changing all the numbers in the parenthesis to its opposite. So 3 becomes negative 3, x becomes negative x, and that's it. Am I clear about that? And then we're gonna bring down positive 4. Bring down negative 4x. Yeah, nothing has changed so far. Bring down the inequality symbol. Bring down 21. Let's keep simplifying the left-hand side. Do we have any like terms to combine, you see? Do we have any like terms to combine? Purple, are they like terms? Orange, they are like terms, right? Yeah, tell me, after you combine the purple and the purple, what do you have? Negative x, negative 4x. combine like terms is to combine their coefficients. Negative x, negative 4x, negative 1, like you owe me 1. Negative 4, you owe me another 4. So together, cumulate, you owe me 1 apple today. You owe me 4 more apples tomorrow. So together, how many apples do you owe me? 5. You see that? Negative 1, negative 4, negative 5, right? They add up to negative 5. Exactly. Thank you. So we have a negative 5x. The orange, negative 3 plus 4. Yeah, negative 3 plus 4. Negative 3 plus 4. What is it? Negative 3 plus 4. 1. Yeah, okay. All right, you see the goal in the bubble? We are trying to isolate the x. Do we need to get rid of the 1 here? Yeah, you can move the 1 over. Yeah, you can move the positive 1 over. You don't change the direction symbol, okay? You do not change the inequality symbol. So negative 5x, you bring it down. 21, you bring it down. Positive 1 becomes negative 1 when we move it over. So the left-hand side, negative 5x. Right-hand side, 21 minus 1, of course, is 20, right? One more step to isolate the x. How do we get rid of the negative 5, the coefficient negative 5? Divide, right? So divide negative 5x by negative 5. Divide 20 by negative 5. Do we need to do something special? Very important. Yeah, switch the direction of the inequality symbol. Very important. Even, yeah, it sounds funny. Even I repeatedly emphasizing, still there are some people don't get attention. So 95 cancel 95, we have x isolated. What is 20 divided by 95? Negative 4, right? Correct? Yeah. So solution set on the inequality contains all the real numbers bigger than negative 4. Yeah. All the numbers bigger than negative 4. Those are the solutions on the real number line. If negative 4 is right here, all the real numbers are bigger. So we go to the right or go to the left? Bigger than. Right? Yeah. At negative 4, do we have a bracket or parentheses? Yeah, because negative 4 is excluded. Because negative 4 is excluded. So how do you know it's excluded? Because here is strictly bigger than, right? Strictly bigger than negative 4. So negative 4 is not a solution. So we have a parentheses. That is a one whole piece. So that is a one interval. What's the left endpoint of the interval? What's the right endpoint of the interval? Comma to separate them. Infinity, always use a parenthesis to frame it. At negative 4, bracket or parentheses. Here we go. Yeah, the solution set is an open interval. All the real numbers between negative 4 and positive digit. In other words, all the real numbers strictly greater than negative 4. Those are the solutions of the inequality. Okay, we're going to stop here and continue tomorrow. Thank you guys for coming.